They're not my drawers. Left. Oh, okay. Whatever. That'll do. Okay. So, CSIS. We live in Canada. Okay. So, today we're going to learn a new way to stick. Today we're going to learn a new way to put a linear relationship on a graph. Is this the relationship? So we're going to use the intercepts. We've already talked about one of the intercepts in previous lessons. In fact, it's part of our general equation, y equals mx plus b. What intercept have we already learned about? The y-intercept, which is the place where the line we are graphing crosses the y-axis. Yeah. What do you suppose the other intercept we're going to learn about today is? Yes, very good. Shh. So to start that off, I want to look at an example. Joe loves reading. He picked a career that basically makes it impossible. But in theory, Joe loves reading. And in the summer, he sure does do a lot of it. So if I have $48 to spend at my favorite used bookstore, I got to make a decision. How am I going to spend my money? How am I going to spend my money? So I've got choices. I like comic books. And at my favorite bookstore, that costs $4 a pop. $4 a comic book. Thanks. And novels, and they cost $6 each. So my question is, what combination of these two things could I buy if I have $48 to spend? Put your hand down. Put your hand down. Okay, and I want you to kind of work through this for me, but I want to think about it by looking at the extremes. Let's start with the most extreme examples. And the two most extreme examples would be what? I've got $48.
Buy all comic books, or buy all novels.
Excellent. I could buy all comic books, or I could buy all novels. So go ahead and figure that out. Figure those two situations out. Whatever method you want. Yeah?
You could buy all comic books, but does it include tax or not?
We'll assume it includes tax, because it's a used bookstore. Lady Hamler, she's not paying up tax. If you need to calculate, I'm just going to put one per pair of desks, so trio of desks.
Wait, we're doing tax?
No, don't worry about tax. We're not.
Let's just say it's $3 and 80 cents.
There you go.
Okay. What do you multiply by?
No, please don't. Let me know. Take this away. Just take it away. That you want it? Yeah. I ripped it off her. I ripped off her binder and went really fast. Oh, that's some big math.
Okay, come on. What are you doing? Oh, yeah.
I'm gonna open my brain.
Grade 11.
It's gone. But there's brain
Dude, there was a kid yesterday that was need to go.
Wait, am I supposed to pick one?
I want to know how many comic books could I buy if that's all I bought? How many novels could I buy if that's all I bought? I've got $48. I'll be waiting.
Wait, separately or the
Yeah, I want to look at the extremes. Let's imagine I take my $48 and I buy just comic books. How many could I buy? Then imagine I take my $48 and I decide I'm going to buy just novels. How many could I buy?
by 12.
That's the nice thing. If your taste is for books that are old and you can find them in a used bookstore, you can save a lot of money relative to people who like new books. I go to Lady Hannelor's in St. Catharines. Place is like a decrepit old building that looks like any moment it's going to fall over. But cheap books.
I'm not a pencil graph.
Sorry? Yeah, I do. I haven't collected. No, that's a different old lady. And actually, old lady Hannelore is dead, but it's still called Hannelore's Bookstore. But now her daughter runs it. It depends on the book. A lot of stuff's in pretty crappy condition, but some of it's in pretty good. Yeah.
Isn't the house that's full of books?
Yeah.
Yeah, that's why I get books.
Yeah. It is a great place. I'm constitutionally incredibly cheap. There's something just ingrained in me. The idea of paying full price for something I could get cheaper just makes me feel crazy. Okay. So here we go. If I'm buying just comic books, what do I got? How many can I buy? Yeah, good. How'd you do that? Yeah, good. So look, if we have $48 and it's $4 a comic, we can just divide that, and that gives us 12 comics. Okay, good. That works. What's weird? Well, it looks like a W. Everyone's a friggin' critic, man. All right, there we go.
I'll get out of here.
Okay. Shh. What about novels? Good. And how'd you do that? You're totally right, of course. Good. So $48 divided by $6 per novel. And through the wonder of dimensional analysis, even though you don't know you're doing dimensional analysis, but if I get you in chemistry, you'll learn all about it, we can get 8 novels. Okay. So now, here's what I'd like to do. Believe it or not, these two cases, these two extreme cases, are actually going to give me all of the information I need to know all of the possible combinations I could have got. Isn't that interesting? Just by doing A, the two simplest cases, right? Because it's very easy. It's very easy to. So you just tell me what's convenient for you, please. I'll just kind of sit up here collecting my paycheck, and when it's convenient for you guys for me to keep teaching, then I'll go there if that's cool. Is that all right? Is now convenient? Now is a good time? Okay, good. Be quiet. Come up here, please. Yeah. Yeah, the idea with be quiet wasn't be quiet until I start talking and then immediately start talking again. It was actually to be quiet. That was the instruction. So looking at these two simple cases, we can actually use that to find all of the possible cases. And what I want to do with that is this. We're going to pick one of these to put on the x-axis, one to put on the y. Doesn't matter which is which. I usually go in alphabetical order, so why don't we make comic books our x case? And why don't we make novels our y case? Doesn't matter. You can just as easily go the other way, but we're going to do this. So down here, we're going to put number of comic book spot, because that's our x-axis. And on the y-axis, we will put what? Very good. So now, let's look at this. This 12 comics, that really means I bought 12 comics. And how many novels? 0. None. So let's put that on our graph. 12 comics, no novels. Put it on the graph. I'm glad that the graph actually printed today. I felt very guilty yesterday when it didn't. These are the kind of things that I feel guilty about.
Sorry, so what are we doing?
So I want you, no problem.
Why is the dot up there?
I'm just showing what color I'm going to use. Sorry, yeah, I just put it there to show you the color I'm going to use. So I want to say, when I bought 12 comics, I bought no novels, right? 12x, no y. 12 comics, no novels. Put that on your graph. And presumably, you'll have something that looks like that. Yeah? Great. What would the coordinates be when I bought 8 novels? Is that true? 0, 8. Very good. 0 comics, 8 novels. What color should I use for that? I'm going to use green. Oh, I like purple. That was exciting.
Can you do neon blue?
I already said purple, but you get me next time. Okay, there we go. And where's that going to go? Perfect, which is 0, 8 would be right here. 0 comics, 8 novels. Those are the 2 most extreme cases. But interestingly, now I have 2 points. What can I always do when I have 2 points? Yeah, very good, both of you. You can always make a line. Yes, sir. So, I don't really have a neon blue, but I've got, this is an exciting looking blue. It's kind of a greeny blue. I don't know. I'm not good with colors. Is it? I might have made. Do we not like that? I like it. Yeah, it does occur to me that is, I like it. It's a little much. Okay. So now, let me ask you this. We now have a linear relationship, but could I go there and do this? Could I buy, what's that work out to? 1, 2. Could I buy 2.5 comics and 6.5 novels?
No.
No. Does that make sense? So I want you to look at this line. I want you to look at this line, and I want you to approach it with some common sense. If we draw a very careful straight line between these, what are the combinations that actually work? Yeah, Alex, what's one combination that actually works?
3 and 6, so 3 comics and 6 novels.
Very good. 3 comics, 6 novels. That works.
Shouldn't it be 6?
What's this?
Why not?
What'd you say?
Shouldn't it be 6? Isn't it like
What do we always put
first
for?
and
No. What alphabetical order?
then- Oh, okay.
Alphabetical
My
order.
bad.
Yeah, that's okay. That's okay. Yeah.
6 comics and 4 novels.
Very good. 6 comics and 4 novels works. Any other points that work?
Do,
Okay, and how would I write that as an ordered pair?
2 or not 2 or not no, yeah, 9 comics.
Very good. No, don't be sorry. You got it. Good job. Okay, there we go. 3, 6, 6, 4, 9, 2. And of course, the original points, 0, 8, and 12, 0, right? Those are the possible values. Does that make sense? So rather than having to do a bunch of math, we looked at the 2 simplest cases, the extreme cases, and we were able, Dear God, I can't talk today. We were able to find all of the combinations that work.
More, but that would require having a remainder of money.
That's right. That would require having a remainder of money, or, yeah, this assumes I want to spend all of my money. Or it would require, no, I'm trying really hard. Or it would require us to buy a fraction of a comic book or a fraction of a novel. And I don't know how your comic book store works, but I have found when I go rip the last 2 pages out and then ask if I can get it cheaper, they usually aren't very amenable to that as an idea. So I suggest you not try it. Yes. Exactly. My favorite book of all time ends mid-sentence. And it's very jarring. It's a 1,300-page book, and it does not come to an end, and it ends in the middle of a sentence. And I was convinced for years that there was not for years, that's not true, but like for a week that there was something wrong with the copy of the book I had bought. So I ordered another copy of it. So that was just how the book ended, and it was very unsatisfying. But still,
It's probably because they wanted to buy low school.
no, it's by I think, the greatest author of the 90s, a guy named David Foster Wallace. It's a bit thick, it's a bit heavy. Like not like physically, yes, but also like it's confusing stuff. But David Foster Wallace, I think he was like the wunderkind. It's called Infinite Jest. Infinite Jest. You know, just to describe the plot would be quite confusing, but I'll give you the Coles Notes version. It's about a post-apocalyptic future in which there's been a nuclear event in North America, and a bunch of wheelchair-bound assassins from Quebec have found a videotape that is so entertaining, people who watch it literally amuse themselves to death by forgetting to breathe or do anything else, and they're using this as a terrorist weapon against the United States. And so, of course, the action centers on a tennis academy in Boston.
Wait,
That's totally true. If I haven't already hooked you, I don't know what else I could say. Yeah.
Can you read the title of the book so I can get the book?
Yeah, you bet.
it's about North Korea's new.
No, it's not. In the meantime, shh. In the meantime, it's a Shakespearean reference. Infinite Jest. Alas, poor Yorick, I knew him. Horatio, a man of infinite jest. A man of infinite jest. Okay, anyway. Okay. Shh. Without realizing it, we just did the last question by finding the intercepts. By finding the intercepts of the example above. Right? And we do that because the y-intercept is this place where the line strikes the y-axis. The x-intercept is the place where the line strikes the x-axis. It is mathematically always quite easy to find these points. So the reason we graph this way, you can always graph a line from 2 points. We pick these 2 points because they are easy to find. Easy to find. You can use any points. We use these points because they're simple to find. So the x-intercept is the x-coordinate when the line crosses the x-axis. Where does it hit the x-axis? And we find this when y equals 0, right? We get the x-intercept when y equals 0. My grade 9 math teacher was a lady named Marg Epp. She was old and she was terrifying. She was a great teacher, great lady. But she used to walk down the hall and she would point at you and snap and say, x-intercept. And you'd have to say, y equals 0. Or she'd point at you and say, y-intercept. You'd say, when x equals 0. And then she'd just walk on down the hall. Unless you got it wrong, and then you're in for misery. Then it was off to Miss Epp's class for math help. So you wanted to make sure you were ready and on the ball. So we get the x-intercept when y is equal to 0. When there is no y, you're on the x-axis. You're right on the x-axis. Yeah. I never thought to, no. What about the y-intercept? We find that
when x is 0.
When x is equal to 0. When there is no x, how much y? That's the y-intercept. When there is no y, how much x? That's the x-intercept. Yeah, it is. It's one of the great questions of life, really. Or it isn't. But this is how we can find the 2 intercepts. So let's do that below. Yes, sir. Of course. Yeah, absolutely. Okay, we have an equation. 3x minus 2y plus 6 equals 0. This equation's in standard form. Now listen, if it were in normal form, if it were in intercept form, then I would graph it the easy way. I would put the y-intercept on, I would count up, I'd count over, and be done with it. So if you have an equation in standard form, you could do what we did yesterday, just convert it to intercept form. To be honest, that's probably still what I'd do. But another thing you can do that's quick is find the intercepts. I would never find both intercepts in y equals mx plus b form. That's just a waste of time. That's more work than is necessary. We know how to graph a line in y equals mx plus b. You put the intercept on, then you count up and count over, put your next point, draw a line, done. Easy. But in this case, let's find the two intercepts. What intercept do you want to find first? X or y? Doesn't make a difference. All right, let's find the y-intercept. What did I do? Okay, let's move on. So we find the y-intercept when what is true? When x is 0. When there's no x, how much y? That's what the y-intercept means. So we're going to say, let x be 0. That's how we get this point. We find the y-intercept by letting x be 0. Well, with that in mind, we would say, let's go back to this equation, 3x minus 2y plus 6, but x is what? So 3 times 0 minus 2y plus 6 equals 0. Well, what's 3 times 0? Yeah, so what remains? Equals 0. And now how would you solve this? It occurs to me I wrote much bigger than I should have. Let's solve this for y. That's going to give us the y-intercept. Oh boy. So we let x be 0, because that's where the y-intercept is going to happen. We know x. X is 0. Now we're going to solve for y. How do I solve this for y? What would you do first?
Subtract 6 from both sides.
Good. I would subtract 6 from each side. And what will my next line be?
-2 equals -6.
Negative 2y equals -6, right? Great. What would you do next?
Divide both by -2.
Divide both by -2. And when we do that, what do we get? Y equals 3. Good. That's the y-intercept. And I'm going to put that in coordinate form, because that's when x is equal to 0, y is equal to 3. And I'm going to put it on the graph. 0, 3. There's my y-intercept. I wish I'd left myself more space. That's okay. We're gonna go over here. Okay. So we have the y-intercept. What do I need to find next?
The x-intercept.
Very good. So we're going to find the x-intercept. And to do that, we're going to let y equal 0. Because the x-intercept is when we have no y, how much x do we have? So we're going to use this equation again, but this time y is going to be equal to 0. So we have 3x. What next? Yep. 3x.
3x.
I'm using the equation. I'm going to use this equation.
Minus 2 bracket 0.
Good. Minus 2 bracket 0. Was it plus 6?
Yeah.
Plus 6 equals
0.
0. Good. Okay. Now, what is 2 times 0?
0.
Okay. So 3x plus 6 then equals 0. I can just eliminate that middle term, because 2 times nothing is just nothing. So there's no reason to take nothing away. Just get rid of it. What would you do next? Yeah, we'd subtract 6 from both sides. What will that give me? Great. And then what would you do? Divide by 3. Divide by 3. And what will that leave me with? X equals -2. And that gives me the coordinate -2, 0. Because remember, this happens when y is equal to 0. Yeah, can you see them both there? Or is that too small? You're welcome. I'm glad that you can see that. I would not be able to see that. Because I'm old. My eyes don't work. And now that I have these 2 points, what can I do? Yeah, I could absolutely find the slope. Even easier, I can just connect them. That's not perfect, but that's pretty close. It'll do. It is, as they say, good enough for rock and roll. Which is all I ever wanted to be, really. Okay, that's it. To find the y-intercept, we let x equal 0. By the way, as you get good at these, you will see that you don't even need to show all the steps I do. If we're letting y equal 0, we don't even really need to include that y term, the negative 2y. We learn quickly that we can just write it without it. If I'm letting x equal 0, we learn quickly that we can just pull that x term out with a bit of practice. So they come really quickly, actually. You will get the habit of this, the hang of this, quite swiftly, I'm sure.
Show up at school tomorrow. It's not my fault. Wait,
Okay,
are you gonna kill me tomorrow?
Yes.
that sounded a little menacing.
I'm not gonna kill you. She's gonna kill me.
Okay, I would like you to try graphing the next example, 5x minus 3y minus 15 equals 0, using the intercepts, please.
Wanna go? No. Because I slapped like that and you're just like.
Yeah, I want you to find the x and the y-intercept and then graph it, please, the next example. I'm going to come around and say things like, hey, come on, try.
Oh my God.
For a second, I thought you were just gonna go.
I don't even know where you're kicking around. I can't do it. I'm just going. I don't own any anymore.
Good work, Kelka.
Orlando. Lane, you'll get knocked out by a little brother. Orlando will car stop here.
First of all, that's awful. Second of all, I'm all time. I'm astonishingly helpless. Do I look like I'm out for fighting? I assure you.
Mr. Orlando, I'll join you. No.
Yeah. All right, Lane, get to work.
Oh,
No, truth is, I'm a pacifist. I don't believe in violence. Also, I'm very bad at it. I believe in it, I'm not good at it. All right.
That's negative.
Let me take a look.
That's negative. Why would no? But if you bring it over to the left side, that would be positive.
I want you to
That's
find
wrong.
Mess up. Oh, how are you dumb? Negative at first, move to the other side, positive. That's what I did. Yeah, okay. This is the equation right here. I'm saying let y be 0. Yeah, okay. Let x be 0. Let x be 0, right? Oh, okay, I get it now. What are you
I
getting
know
negative?
I'm funny. I'm also very funny looking.
Okay. Trying to find x, right?
I would tell you if you're funny.
I'm trying.
I would like to
x
do this
be
math.
0. Okay. Let x be 0. Look, it's -5.
Done. I don't like that.
And then like.
Oh, God, I think that's it. Right in the back.
I like math.
Stab me right in the back.
Does that make sense? Yes. That's what I was gonna do with her. Wait, you're gonna stab me?
Right in the back?
We were going like this in class because she started hitting me, so I hit
Don't
her back.
hit each other. We
And
don't
then
hit.
I got bruise all like here. And I
We
have a
don't
bruise
hit.
right here.
We don't hit.
I go
We
like
don't
this.
bruise.
Just a little slap, and she's like, "No, you're like this."
So, Alex.
That's true. Thank you.
Do you guys know this?
Okay, guys, shh. I hate to do it. I would like to leave you. Yeah, of course. Yeah. I would. Shh.
I didn't mean
I'd like to go around and see everyone's work individually, but as happens from time to time, I have let time get away from me a little. Perhaps it was the incredible number of useless diversions, for which I apologize. But let's look at this first. Do you want to find the x or the y-intercept first? It makes no difference.
Why do you guys want to find it?
Okay. First, we're going to find the x-intercept. Now, we find the x-intercept by doing what? Yeah, we let y equal 0. Okay. So if y equals 0, this term here is going to be 0. It's going to be gone. Does that make sense? So I don't want to stress you out, but I'm going to try writing it this way. I'm going to try just short forming it. If there is no y, this disappears. So what remains? 5x minus 15 equals 0. Is everyone comfortable with that? Please tell me if you're not. Yeah. So I didn't include this middle term because I know I am saying to the equation, hey, y is equal to 0, which means negative 3y is going to be 0. It's going to be nothing. So to save time, I'm excluding it. Please tell me if that's too big a leap. I'm happy to write the middle term in for now, but it's a good habit to get in, not writing things we don't need to write. So now, how would you solve this? What would you do next? Yes. Very good. I'm going to add 15 to both sides. What then will I have as my next line?
21.
Yeah, Lexi. Equals what? I'm sorry. Good. I'm not going to lie. I didn't actually hear a word you said. So I'm going to assume that you said 5x equals 15. Am I good? Thumbs up? Okay. Shh. I've been doing that all class. Just writing the right answer and assuming the people said the right thing. And I'm hoping that's cool. What?
There was no tricks this time. I didn't put like.
That's true. I didn't. Okay. Maybe I will here. Who knows? And then what should I do?
X is equal to 3.
Well, how'd you get that?
Match it. Divide both sides by 5.
What should I do? Good.
I like how Caitlin gets all the answers.
Yeah. Yeah.
She barely participates. And then you people
She's
just throw them out.
she's following the rules. She set the rules. Yeah. Okay. You'd be astonished to know how little I care. Be quiet. Okay. Shh. Shh. Don't fight. Don't fight. The important thing to me. The important thing to me is that you're all doing a lovely job. So let's put the x-intercept on here. 1, 2, 3. There it lives. There's the x-intercept. Now, we need to find the other intercept, which is, of course, the... Yeah. Shh. Stop fighting. Okay, to find the y-intercept, what do I have to do? Okay, to find the y-intercept, we're going to let x equal 0. Good. Now, with that in mind, let's look at this equation. What term disappears now? 5x, because that's just 0. What are we left with? Negative 3y. Good. So negative 3y minus 15 is equal to 0, is what remains. And how would you solve this? Yes, you would. I'm assuming you said add 15 to both sides. You got it. And what line does that give us? What do we have now?
Minus 3y equals 15.
Very good.
Wow.
Spot on. Well done. And what does that give me?
Sam.
No pressure. Just if you're wrong, I'll be sad forever. Very good. Not gonna lie, I didn't actually hear you, so I'm just assuming you said it. Oh. Okay. Okay. And where does this go on my graph?
0, negative 5.
Very good.
Left.
And now, of course, I connect them with a line. All right, guys, have a wonderful day. I'll see you tomorrow. Be kind to one another.
I can't
That's gonna be
promise.
hard today. It's still Orlando.
Don't do anything Lane wouldn't do. Yes.
I always do. Can you do me a favor?
Yes.
Grow a beard.
Grow beard? I grew a beard twice in my life, and both times it was a special kind of